Welcome back, everyone. If you're gearing up for the Kerala PSC pump operator exam, you are in the exact right place. Today, we're jumping straight into an absolutely crucial topic, the starting methods of induction motors. This is one of those areas where you're pretty much guaranteed to see questions on the exam, and once you get the hang of it, it's a super easy place to score points. Let's dive right in.
Okay, here's our roadmap for this explainer. We're going to start by looking at the starting current problem, then move on to direct online, or DOL starters. After that, we'll tackle star delta and auto transformers, and then look at the smart tech, soft starters and VFDs. Finally, stick around for the end because we'll be doing a quick-fire PSC exam review to test what you've learned. Section 1, the starting current problem.
Have you ever wondered what actually happens when you flip the switch on those massive motors at a large pump station? It's not just a simple hum. So ask yourself this. What happens if a large induction motor is connected directly to the power supply? On the outside, it might seem completely fine, but inside the electrical system, you're literally opening the door to a disaster. The scale of that disaster really comes down to this number, 5 to 8. When an induction motor starts up, it suddenly pulls an enormous surge of current, anywhere from 5 to 8 times its normal full load current. That's a massive spike. Because of this, the system's voltage takes a sudden nosedive, causing lights everywhere to dim. And worse, this massive current can actually cause cables to overheat, and, in extreme cases, even catch fire. Not exactly what you want happening on your watch, right? So, to solve this, we bring in our hero, the motor starter. Simply put, this is an electrical device designed to safely start the motor while reining in that dangerously high starting current. If you want to protect your expensive machinery and avoid wrecking the rest of the electrical system, having a motor starter is absolutely non-negotiable. Moving on to Section 2, Direct Online or DOL. Let's look at the most basic starter out there, the DOL Starter. It's got a wonderfully simple setup. You've got an MCB or MCCB to manage the main supply, a contactor to actually connect and disconnect the motor, and an overload relay to keep it safe from, well, overloads. Plus, of course, those classic green and red start and stop push buttons. It's totally perfect for smaller motors, but here's the catch. It doesn't reduce the starting current at all. It just connects the motor straight to the supply. That brings us to Section 3, Star Delta and Auto Transformers. Since DOL only cuts it for the small stuff, what about the heavy-duty industrial water pumps? That's where Star Delta starters come in. And the way they work is actually pretty brilliant. Step 1, the starter fires up the motor in a star connection. This clever little trick drastically reduces that massive starting current we talked about earlier. Then, for step 2, once the motor builds up enough speed, the starter automatically switches it over to a delta connection to run at full power. If you end up working at a large Kerala Water Authority pump station, you're for sure going to see these everywhere. Now, for the really massive industrial machines, we step up to the auto transformer starter. This relies on applying a reduced voltage initially to get a nice, smooth start, and then it kicks over to full voltage once things are moving. For high-powered motors and heavy-duty machinery, this kind of voltage reduction tech is essential. Next up, Section 4, Soft Starters and VFDs. Tech has come a long way, and modern pump stations are all about ultimate control. Let's compare two of the smartest tools we have. First, the soft starter. Its main job is to gradually increase the voltage, giving the motor a super smooth start and cutting down on mechanical wear and tear. But the VFD, or variable frequency drive, takes things to a whole new level. Instead of just tweaking voltage, a VFD actually changes the frequency of the power supply. This means you can completely control the exact speed of the motor. For maintaining precise water pressure and saving a ton of energy, VFDs are a real game changer. And finally, Section 5, the PSC exam quick review. We've covered a lot of ground today, so let's shift gears into a rapid-fire quiz to see what stuck. These are exactly the kinds of questions you'll see on the CSE exam. First up, what is the full form of DOL? Think back to that very first, most basic starter we looked at. It's direct online. Pretty basic, right? But you've got to have those foundations down. Let's keep the momentum going. Question 2. What is the main advantage of a Star Delta starter? Why do we bother using it for all those large water pumps? The answer? It reduces the starting current. This is absolutely vital for making sure the whole pump station doesn't overload when you flip the switch. Awesome. Moving on to question 3. And this one is all about that smart tech we just covered. What device is used to actually control motor speed? It's the variable frequency drive, or VFD. Remember, by controlling the frequency, you control the speed. It's really that simple, and it's a huge deal for energy efficiency. Okay, last question, and this one is all about safety. Which specific part inside the starter is responsible for protecting the motor from taking on too much current and getting damaged? We saw this early on.
The overload relay. It literally acts as the motor's personal bodyguard against electrical damage. Definitely keep that one in your back pocket for test day. To lock all this into your brain, I've got a quick memory hack for you. Just remember the acronym DSAV. That stands for small motors use DOL, large motors use star delta, heavy-duty needs auto transformers, and for variable speed, you use a VFT. Just remember DSAV, and you're going to save yourself so much time in the exam hall. But hey, it's not just about passing a written test. This is about being a great pump operator in the real world. Connecting all this theory to your actual job, remember that doing a daily inspection of the electrical panel in those starters is one of your absolute most important duties. You've got to make sure they're running exactly as they should be. I hope this explainer really helped clear things up for you. But before we wrap, think about this for a second. How does manipulating voltage completely change an entire power system? Well, that is exactly what we're tackling in our next study guide on transformers. Make sure to review today's material, and we'll see you in the next one where we unpack the magic of voltage. Thanks for joining us.